All right, let's talk about factoring polynomials completely. So we're going to look at these guidelines for factoring completely. First step is look for your greatest common monomial factor, find the GCF and factor it out. Second thing to look for, do you have a difference of squares? Do you have a perfect square trinomial? So remember, difference of squares factors. Here's an example of one right here. A squared minus b squared equals a plus b times a minus b. If you recognize something as a perfect square trinomial, that will make the factoring quicker. If you don't recognize it, it's not a big deal because we can factor trinomials and perfect square ones as well using our box method that we've learned. Fourth thing new today is if you have four terms, factor by grouping. So we're going to go through those as we do some examples here as well. So example 2, factor completely. So 3x to the third plus 6x squared minus 18x. First thing is look for our greatest common factor. Look for that GCF. 3, 6, and 18. 3 is the smallest, and it will divide into 6 and 18. So we get 3, and then x to the third, x squared, and x all have a factor of x in common. So we'll take our GCF of 3x. Now remember, we're dividing each of the terms of our polynomial by 3x. So we 3x to the third divided by 3x, we've divided out the x. Oops, we've divided out the 3. We've divided out a single x, so there are 2 left. 6x to the second divided by 3x, 6 divided by 3 is 2. And x squared divided by x, we have a single x left over. 18 divided by 3 is 6, and we've divided out the x, so there we have it. Now, the next step in our factoring process is we have a trinomial, and it's definitely not a perfect square because 6 is a perfect square trinomial because 6 is not a perfect square. But we're going to do a times c, which is negative 6. We're going to look for 2 factors of negative 6 that add up to 2. What are the factors of negative 6? Negative 1 and 6. 1 and negative 6. That sum is is positive 5. Negative 1 plus 6 is positive 5. That's not going to work. If I switch the position of the negative, that's not going to work either. Negative 2, positive 3. That gets us a sum of 1. That's not going to work. Neither would 2 and negative 3. So this polynomial is factored completely. The x squared plus 2x minus 6 does not break down any further. All right, part B. First step, find your greatest common factor. 7x to the fourth and 28x squared. See, 7 is a factor of 28, and x squared is a factor of both the x to the fourth and the x squared. So our GCF is 7x squared. We will factor that out. 7x to the fourth divided by 7x squared. We've taken out 2 of the factors of x. That means there are 2 left. And 28 divided by 7 is 4. And we've factored out both of the factors of x, the entire x squared. Now, what do we have? We have a squared minus b squared, where a is x, b is 2, because that is x squared minus 2 squared. So we can factor that as x plus 2 times x minus 2, and then we have it completely factored. Okay, example 3. Once you have these down to first degree binomials, they're not going to go any further. So those 2 factors won't break down any further. Okay, so example 3. I'm going to throw in another example that's not in big ideas. 4x to the, oops, that's not it. X to the fourth minus 2x to the third minus 5x squared plus 10x. We're going to factor that. Now, first thing remember is to look for a greatest common factor. Do you notice every one of those has a factor of x? So our greatest common factor is going to be an x. The x to the fourth has a coefficient of 1, so our coefficient on our GCF is a 1. Divide each of the 4 terms by an x, we get this polynomial. And then, because we have a polynomial with 4 terms inside those parentheses, we're going to factor by grouping. So I'm going to group first 2 terms, second 2 terms. Now notice what I'm going to do. I'm going to write that subtracting 5x as a plus and negative 5x. You can do it a little bit differently, but somehow we have to realize that that there's a sign change here. I'll show you what I mean in a second. So we're going to take the first group, GCF for the first group is x squared, so pull out an x squared. As we look at these 2 terms, the greatest common factor there is an x squared. When I do my second group, I'm going to take out a negative 5. (10 divided by negative 5 is negative 2. Notice there's my negative 5x plus 10. You should be checking these signs to make sure you've got the right thing here. And then the x minus 2 comes out as our greatest common factor, and we have x squared minus 5. 5 is not a perfect square, so we can't factor this as a different squares, and we are finished right there. And that's our solution. Okay, we're going to move on to the monitoring progress. Actually, I'd like you to pause the video, see if you can do the monitoring progress problems, and then check your answers. Okay, problem number 3 in the monitoring progress. Notice we have a greatest common factor of 3x. So our first step is the GCF. 3 divides into 12. We do have a factor of x, so we'll take out a 3x, and then we have x squared minus 4. X squared minus 4 is the same as x plus 2 times x minus 2. And we've got a factorization. Problem number 4. 2 divides into 12 and 18, so my greatest common factor is a 2. Notice they all have a y, so we'll factor that out. And then we have y squared minus 6y plus 9. You might notice this one is a perfect square trinomial because 9 is 3 squared. The 9 is 3 squared. And the 6 is 2 times 3. So it fits our perfect square trinomial pattern. So we can make it y minus 3 times y minus 3 or y minus 3 squared. But we could also factor this trinomial y squared minus 6y plus 9 using our table method. That would be perfectly fine as well. Okay, number 5. 3 terms, all of them are divisible by m. Greatest common factor is m, so we'll take out an m. Then we'll factor the trinomial. Can use our table method, or we can take the negative 8 and break it down as, we need a sum of negative 2 if we do 2 and negative 4. And those are the solutions for the monitoring progress. There we have it. We are not going to do the problem on the next page because it requires some things from section 2.4, which will be next time. And so there we go.